Hey everyone, and welcome to your C++ tutorial on encapsulation. So as you can see, I have Visual Studio Code pulled up here. I have the entry point of our program, our main function here, but I also have our car class. And inside of our car class, we have a public integer for miles. Now, let's begin with a quick definition on what encapsulation is. And so we can think of encapsulation as bundling data with the methods that operate on the data. Right? So bundling data with the method or methods that operate on the data. And a lot of times that involves using public and private access modifiers, which we'll also get into this tutorial. But just as an example of what this bundling means, I'll use our car class. So in our car class, we have an integer called miles. So this is our data, right? This variable is our data. We can create a method, which is just a function inside of a class, right? So we can create a method that operates on miles. And if we create it inside of this car class, this is considered, bundled together. So you can think of encapsulation as sort of like the logical bundling of data with methods that operate on that data. So let's edit this a little bit and we'll say logical bundling of data with the methods that operate on that data. And this logical part is kind of just our sort of definition for it. Okay, so let's take a look at how to declare a method in our car class. So we're going to be creating a method that just prints out miles. It's very simple. So we're going to use a void return type, which means that there's going to be no return type for this method. And we will call this one print miles. It'll take no parameters. And then inside of our function body, we are just going to print out miles. And then we're going to print out our variable here, miles. So what you've noticed is that we don't have miles set to anything, so we're going to need to set miles to something. This can be achieved actually through a setter, which we will talk about in one of the next tutorials. But for now, we're just going to worry about the relationship between a member variable and a method here that's using the member variable. So you can see that this method here is operating on this data, right? It's printing out this data because miles is our data here. So now what we can do is we can invoke this method. So invoking a function that's inside of an object is a little bit different than invoking just a regular function that's just in the ether, sort of. So what we need to do first is we need to create an instance of our car class. And I'm actually going to delete this hello world here. So we'll create an instance of our car class. So car is our type because a class creates a type. And we'll call this class Camry, and we're going to set it equal to car. And that'll do it. So as we know, this is how you create an object. So car is returning a new car object and storing it in this Camry data space. Then what we do is we use the Camry object and call print miles as a function there. And so if we compile this in our G++ compiler, and then we run it, we see that miles is equal to 0 because we didn't set it to anything, right? And so the default is nothing here. And we're going to look at in subsequent videos, maybe the video after this one, on how to initialize an object using a constructor so that it has a value initially. But for now, what we're trying to stress in this tutorial is just the relationship between a method that operates on data and the data stored in the object and the relationship between these two. What we can get into now is the public versus private sort of relationship. So, you might have been wondering, well, hey, if we have miles and it's public, why don't we just print out miles in our function down here? Why do we need to have a method to do that? And that's accurate. With how things are structured right now, we can totally do that. Doesn't really make sense to have a print miles method. So what you would generally want to do, though, is you want to hide your data so that it can only be accessed on your terms, right? And this involves a getter and a setter, which we're going to get into later. But for now, what I'd like to do is I'm going to make miles private and miles. And so what this does is when a variable or a method is public, that means it can be used outside of our scope here. So you can see print miles is accessed in the scope of main. These are called access modifiers, public and private, because they modify your ability to access them. So now, if we compile this in our G++ compiler, you're going to see that everything sort of works as it did before. But what we can't do now, though, is we cannot, using our car instance, we cannot access miles. So if I try to do miles here, that's not going to work, right? So we can do a cout, we'll say car miles, and if I compile this now, using our G++ compiler, we get an error saying use of unidentified, sorry. Let's try Camry. That's my mistake there. So that's definitely not going to work. Now here we go. So miles is a private member variable of car, which is our error here. So we can't access this anymore because it's private. You see, it says miles is a private member variable of car. So the compiler's smart enough to know, hey, the car class, it does have a member variable named miles, but we can't access it, right? Because it's private. We can access print miles because it's public. And now what that allows, the reason that that's powerful is because now we control how our data is being used, right? We control how the data is being printed out. So if we wanted to, format the data in some certain way, or we wanted to guarantee that the data was between a certain set of parameters, we're free to do that. When we have a public member variable, it's not wrong, but it's not advantageous in a lot of ways because it allows people to just change the data willy-nilly however they want to. So there's a lot of benefit in keeping your data private and only accessing that data through defined methods that you create. And this is the way that you begin doing that, is with these public and private access modifiers, right? Public meaning it can be accessed from anywhere, and private meaning it can only be accessed inside the scope of the class. So just to recap, we have our car class. Encapsulation is the bundling of data with methods that operate on that data. In our car class, we have miles as our data and print miles as our method that operates on that data because it's using that data right here. We've extended encapsulation a little bit further, and we're using our public access modifier and our private access modifier. Public access modifiers expose functions and data to the public. Private hides data and functions so that they can only be used internally inside of this class. The benefit of having private data is that with public functions, you control what that function does before it exposes the data or before it sets the data. And that's a getter and a setter. And we're going to talk about that in later videos. But right now, all I'm trying to convey here is the relationship between the logical bundling of methods and data and the public and private access modifiers. So thanks. I hope you learned something.